Okay, if I ask you to take the second derivative, that just means you take the derivative 2 times. So for this first one, I'm finding the first derivative, so I bring the 5 down, so that gives me a 20 x to the fourth minus a 6 x to the second plus 10x. So that's the first derivative in red. So if I ask you a second derivative, you'll see my notation for second derivative here with the 2 little marks, and then you'll just take the derivative a second time. So that's how that part would look. The rest of them in this section are special cases, but they are important, so we'll look at those. Okay, for this next one I ask you a radical question. We'll start with radicals here briefly, but you'll do a lot of radicals a little bit later. Now, you can't work it the way it looks right now, so you have to rewrite it using algebra. So f of x is going to equal x something here. What you remember from your algebra days is that a cubed root becomes a 1/3 radical. 1/3 exponent, I'm sorry. A cubed root radical becomes a 1/3 exponent. This 3 right here is the denominator of the fractional exponent. Now that's algebra. That is not your answer. You haven't even touched calculus. You haven't even touched the derivative. Step 1 is to rewrite it in a usable form. So now that we've rewritten it, now we can take the derivative. The first thing you're going to do in the derivative is bring your power down. Well, right now your power is 1/3. Okay? Now, here's my x. I'm going to go ahead and put it in the top because it's understood to be in the top at this point. And you're going to decrease your power by 1. So that's going to be 1/3 minus 1. Let's come to the side for that for a second. Okay, so you have 1/3 minus 1. So 1 is the whole, and a whole in terms of thirds would be 3/3. So this would be 1/3 minus 3/3, which is a negative 2/3. So this is going to be 1/3 right here, x to the negative 2/3. Now, I'm not quite sure how they're going to ask you these questions, how they're phrasing them in my Math Lab homework, but for me, I always want you to simplify negative exponents. So if you have one on a quiz or an exam, I'm going to want you to simplify this. And remember, your negative exponent rule for algebra says if you have a negative exponent, it moves. So that 1's understood to be in the top and the 3 is understood to be in the top. But this is going to be an x to the 2/3 in the bottom because a negative exponent would move it across the division bar. Okay, here's your next one. One more of those. The first thing we have to do is rewrite it. Right now you know this is understood to be a 2 right here. So rewriting it would be x to the 1/2. Okay, so now we can actually start the calculus. We haven't begun it yet. So to take the derivative, you're going to bring down your power. You're going to decrease your power by 1. Oh, excuse me. I'm so sorry. I couldn't stop the sneeze. So you have 1/2 minus 1. Well, 1 is a whole, so that would be 2/2. So 1/2 minus 2/2 would be a negative 1/2 exponent. So cleaning this up, I get 1/2 x to the negative 1/2. Remember, you can't have a negative exponent, so we want to move it. So this is going to be 1/2 x to the 1/2. Now you're welcome to write it that way, but you might have also seen the problem written this way, because remember, x to the 1/2 is just a radical. Either one of these answers is correct. Okay, now looking at this one, a little bit later on in the semester, you're going to use something called the quotient rule. So you definitely could use the quotient rule for this one, but you also can simplify it out algebraically really easy. Since it only has one term in the bottom, you can actually break this down into 2x to the fourth over x minus x to the third over x, and you can simplify out these fractions. So that would give you 2x cubed minus x squared. Now, that is not your answer. You'll notice that's just your function. That's an easier way to write that same function. So now that we do the algebra step, now we can move on to the calculus part. So taking the derivative of this one using calculus, we would have that as a 6x squared minus 2x to the 1. And that's how that one looks. Now again, a little bit later on, they're going to show you some harder ways to do that one, but that's pretty easy. Okay, also a little bit later on, you'll have something that looks like this, and in this case, you would use the product rule. We haven't gotten that yet, but you will eventually use it. But right now, you can just simplify it using algebra. This is just a matter of FOIL. So if I FOIL this out, I get 12 x to the third minus 3x plus 20x squared minus 5. Let me double check that. 12x cubed minus 3x plus 20x squared minus 5. That looks great. Now, that's algebra. I haven't done any calculus yet. All I did was simplify it algebraically. So now you're ready for the calculus step. So you're going to get 36 x to the second minus 3 plus 40x minus 0, because remember the derivative of 5 is a constant, so it's just 0. And so your answer for this one is 36x squared plus 40x minus 3. And that's how it would look.